Hi, everyone, and thank you for joining us today. I'm Christian Pascal. I'm a connectivity manager at Wolfram Research, based in one of our offices located in Lima, Peru, with a nice view of the Pacific Ocean from here. My group works on connecting the Wolfram language to external services through functions like Service Connect, Wikipedia data, web image search, and so on. And now we are introducing new experimental functions with our new 11.3 version to interact with different blockchains from the Wolfram language. So let's start with a general overview of what we have now. So we have first some read-only functions that will allow you to connect and extract information from different blockchains, and some functions to write to, in this case, our own Wolfram blockchain. So we have this set of 5 basic functions that are fully documented. And with this, you will able to interact with some blockchains. To specify a blockchain, you can use the $blockchain base variable or the blockchain base option. For now, the Wolfram blockchain supports the Bitcoin blockchain, the Ethereum blockchain, and the Wolfram blockchain. So let's start with some cool stuff we can do with these functions. Let's just increase the size a little bit here. Okay. All right, so let's start with the blockchain data function. The blockchain data function allows you to get basic information about a specific blockchain. So let's start with the Bitcoin blockchain. Okay, so with this, I set my default blockchain is the Bitcoin one. This will tell the Wolfram language to use the Bitcoin blockchain with all these functions. So let's try something first. So let's do a blockchain data of the Bitcoin blockchain. As you see, I get some basic information about the Bitcoin blockchain. Blockchain data function, as well as the other functions, support different properties that, again, they are fully documented and they are listable. So in this case, I can ask, let's ask for the latest hash and the blocks, which is the height, the current height of the Bitcoin blockchain. I can do the same with another blockchain, let's say the Ethereum blockchain. I'm currently using the Bitcoin one, but as I mentioned before, even if I have set the $blockchain base variable to Bitcoin or another blockchain, I can change this locally using the blockchain base option. So let's choose Ethereum blockchain here. Let's see what we get. Okay. So again, I get different information from the Ethereum blockchain. As you see, it's different information because there are different blockchains. They deal with different cryptocurrencies and different properties. So let's try doing. Let's get the low gas price, the medium, and the high gas price. So I could do something like, for example, this. Okay. So we have seen some general information about the blockchains. Now let's go a little bit deeper and explore the blocks themselves. So remember, I'm working with a Bitcoin as my default blockchain. So let's just get any random block here. And now I get more information about the block. So let's do something more interesting, maybe. Let's say we can get the latest block by doing blockchain block data -1. This will get the latest mined block of the Bitcoin blockchain. As you can see here, the transaction list is longer than the one we got here. Because this one is a very old block. This one is the most recent one. Let me hide this. So let's do something. Let's get the transaction list of the last block. Okay. And let's say, let's get a random sample of this list. Okay. This is just one random transaction of the last current block. So we can use this to explore our third function here. This is the blockchain transaction data. With this function, we go even deeper into the blockchain and explore a transaction itself. So remember, we have this transaction, and let's try doing blockchain transaction data of this transaction. Okay. So once again, I have a set of properties related to this transaction, in this case of a Bitcoin transaction. So let's do some cool stuff with the Wolfram language. So remember, I saved this as a variable so I don't have to call the blockchain again. In this case, for example, let's get total Bitcoins. That's the total amount of Bitcoins transferred in this specific transaction. So as you see here, we return the data as Bitcoins. So we can do something like this. Since the Wolfram knowledge base also supports and knows about different cryptocurrencies, we can do a currency convert of all these Bitcoins to, let's say, US dollars. So we should get the current price of this amount of Bitcoins, but in US dollars. Let's say we want to explore the fees awarded in this transaction. Once again, we return the fees not in Bitcoins, but as Satoshis, which is a basic unit of Bitcoins. It is also supported by the Wolfram language. So let's say, let's convert these to US dollars. And we could do the same with any other supported currency. All right, so we had this Bitcoin transaction. So what happens if I try to look for this transaction, but in the Ethereum blockchain? Well, this is not going to work because this transaction doesn't exist in the Ethereum blockchain. There are different blockchains, and this one doesn't even have the same structure as an Ethereum transaction ID. But let's keep exploring the blockchain, the Ethereum blockchain. So let's get the last block from the Ethereum blockchain. All right. We have a transaction list here, and let's just pick any random transaction. So we can do, let's say, Ethereum transaction data. This transaction ID using the Ethereum blockchain base. So this transaction exists in the Ethereum blockchain. So let's see what we get here. So again, we have different properties, different from the Bitcoin blockchain. And once again, we can play with these properties using the Wolfram language. Let's say we want to see the total weight. So the weight is the basic amount of ether in the Ethereum blockchain. So we can do a currency convert of this amount to, let's say, ethers, and we get the current price. And let's do this once again. And now let's convert these ethers to US dollars. Okay. So this is all handled by the Wolfram language. Let's return to our Bitcoin transaction. Now let's explore the inputs of this transaction. So let's say I want the inputs, and from here I want to extract the input script. So let's say script byte array. Okay, I have the script now. So we're still working on having a better representation of these scripts, and that will be supported in future versions. But let's see what we can do with what we have here. So let's try to decode this byte array. Okay, we just get some random data, but maybe let's try another transaction from another block. Let's say this one here. Let's extract the transaction list, and I want the first transaction. This is a very old block. And from here, we can do blockchain transaction data to explore this transaction. And I want the inputs. All right. And from here, let's extract the script byte array. Okay, so let's try this one more time to see what we get. Well, at least in this case, we got some metadata from the miner. So with these three functions I just showed you, you can connect to these three blockchains, the Bitcoin, Ethereum, the Wolfram blockchain, and extract information that can be used to explore all this data. So let's now move to the read and write functions. So for now, the Wolfram language supports writing only to the Wolfram language, to the Wolfram blockchain, I mean. So let's change our blockchain base to Wolfram. Our approach is to use a Wolfram blockchain as a public ledger to store any kind of data, just arbitrary data. So let's say, for example, we'll do a web image search of, let's say, a rival movie poster. Yeah. Let's just get the thumbnails. We don't want big images here because we have a block size limit of 8 megabytes. So, okay, let's just try with one of these. Let me get a random sample of this result. And I just want one here. Let me try again. Okay, I'm sorry, I just like the UFO. All right, so we have an image here, and to save data into our blockchain, we just have to use the blockchain put function. So let's say I just want to store this image here. So this should return a transaction ID. This one. Let's save this into another variable. And of course, we can explore the details of this transaction using the blockchain transaction data function. So let's try this here. And as I showed you before, you'll get a set of properties that we can explore again. But let's do another thing. So one cool thing about these functions and our blockchain is that anyone using the Wolfram language that has this transaction ID can get the information I saved to our blockchain just by using the blockchain get function. So remember, we have this, and let's just do a blockchain get of this transaction ID. All right, so I got my UFO, but actually, if you see this, I not only get the UFO, I get a complete structure of a list of one element, which is a UFO. You see here, this is the actual thing I saved. So if I do this, yep, here, I have my UFO. So that is, I can save any kind of Wolfram language expression to our blockchain. Let's say, let's try a random graph. All right, so let's do a blockchain put of this graph. And now anyone with this transaction ID can do blockchain get, and you get the graph here. So I mentioned that we have a block size limit of 8 megabytes. So if we try to save something that is too big, let's try, for example, this. I shall get an error saying that this is too big. So actually, even if the block has a max size of 8 megabytes, the information here has to be a little bit smaller than that because you have to consider the block headers and other data. So these are the functions that will allow you to interact with our Wolfram blockchain and more blockchains in future releases.